let us start quantifying things now. Until now it was too much of abstract thinking, is it not? So, let us talk about now contaminant geomaterial interactions. Interaction part I think I have explained quite a lot, and contaminants are also clear to you, anything which is unwanted, undesirable, clear, which you never expected in the system. And what is our system? Is geomaterials, alright, or micro biogeosphere. If you remember, I sometime back I coined this term. So, in this system, if any contaminant comes, it is not a good situation, but suppose if it comes, I am helpless, I want to understand how the interactions are going to take place. So, the first question which was asked is how would you dispose the nuclear waste, because the more and more furnaces I run, the more and more coal I was using, tandoors for that matter, any type of oven, the more and more ash you are generating, and you had an idea, my ash I will dispose in your home next door, is this correct? That is what happens, their ash comes to your courtyard. So, we will throw it there, they will throw it here, this is how the game was being played. Unfortunately, in this case you can't do this, because there are few watchdogs who are watching what is happening in your country. This is being observed by international agencies. So, one of the options is that you take this atomic waste, contain it in canisters. Canisters are normally made up of lead, because leads are retarders of atomic activity, radioactivity. So, these canisters contain toxic waste which is nuclear in nature, and normally they are stored on the surface with special measures and they are covered. So, this is the compacted geomaterial, and on this I can grow the vegetation and there could be a water table, good scenario. This is what is known as surface disposal, provided the activity of the toxic waste is tolerable. So, most of the waste which is coming out of the R&D units, our gloves, the scientists who are associated with atomic waste, atomic activities, surgeons, doctors who are giving therapies of different types by using different type of isotopes, different type of medicines, weaponries, clear, irradiations of different type of crops, potato, onion, you must have noticed. Nowadays onions and potatoes do not germinate, even if you keep them in your kitchen for several months. Why? During our days when we were kids and when we were of your age, you just buy it today and tomorrow it used to germinate. So, what do they do? What magic they have done? Something interesting they have done, is it not? You agree? So, there are facilities where the truck loads of the agricultural produce go and they are irradiated. Read about this, very interesting way to create a profession for yourself. Another good example is so these are the applications of the units where the activity is being used for different purposes. It is known as surface disposal. So, all these type of waste which comes out of such units is within tolerable limits, and hence it can be contained and buried in a geomaterial. Then the question is, what type of geomaterial I should be using and why? Suppose if I keep it stacked like this on the ground, earthquake comes, there could be the wear and tear of the canister itself, and inside the activity is kept. So, what is going to happen? Everything will become a part of the geo environment, it will spill over. So, whenever nuclear establishments have met with a disaster, which was the recent one which mankind is unable to forget, Fukushima, what happened there? Yes, the beautiful combination of the two things which we have been discussing, clear. So, it is a natural disaster influencing atomic establishment, Chennai, Kalpakkam. So, read what happened there, it is becoming a big issue how to safeguard your establishments. You need millions of liters of water from the sea to run a reactor. So, you can't put it in mainland, clear. One advantage, disadvantage. Second, now disadvantage is tsunamis. When they come, yes, you are very right. What happened in Japan? Fukushima, clear. What happened in Chernobyl? Clear. So, these are the issues. In Kerala, what is happening? What industry is there at Chavra beach? So, the biggest problem is not the titanium. Titanium cannot be mined like this. It is thorium. So, look at the beauty of the nature. Why Kerala is so precious for the guys who are associated with the atomic industry. The nature does magic. The sand which comes on the beach contains lot of activity in the raw form, and this is processed in the Indian Rare Earth Limited. So, they collect sand, is blackish color sand. Now, next time when you are there, please go and visit this site, alright, and you say that you are from IIT Bombay and you know the whole story and you like to see what is happening there. So, they do forming of sand. Each time wave comes, it deposits. I do not want to lose this, no, otherwise what will happen? It will go back. So, they do literally scraping of the top layer of the soil from the beach, they process it, they keep it aside, next batch comes. But now what is going to happen because of this? Yes, suppose if this process goes on and on and on, you are not returning anything to the sea, what is going to happen? Beach erosion, and that is what is happening in most of the areas nearby. So, I drove all through the entire belt of Malabar belt, and this tremendous problem with the country is facing. Hope you are realizing now the issues. Each city has its own issues. Groundwater, and we will talk about why industrialization could not be done, why atomic industry is flourishing, and issues related to geo-environmental aspects. So, the question here is that what type of geomaterials should be utilized? So, the question mark here is that what type of geomaterials I should be using, from where they will come. So, selection of geomaterial itself is a question mark. What properties these materials should be having? They should be protecting this unit against the rains. Compacting them itself is a big challenge because the buried units are there inside and these buried units are quite active. So, you can't just say I am compacting it. Okay. The properties which are required, nothing should come out of it in any liquid phase, gaseous phase. Okay. Water table should not fluctuate so much that everything becomes wet. Forget about the instability which you can take care of. Vegetation should be done because plants ultimately provide a cover. Look at the second situation. Yesterday I was asking this question, whether I should go above the ground for disposal or I should go beneath the ground. Clear? Which one is better? No unique answer. I mean, I will sometimes choose this, I will sometimes choose this. I might make a trench over here, few tens of meters deep. I will design a good engineered backfill. On the top of this, I will keep the toxic waste canister and bury it. Make it perfectly sealed, so that even if water table fluctuates, nothing should permeate into and out of it. Now, this is normally done for near surface disposal. There are a lot of facilities in country which have been created known as NSDF, near surface disposal facilities, where most of the geotechnical engineers are working right now. They are giving solutions. The third one is deep disposal. You go quite deep inside the ground. This is hundreds of meter deep, and where you encounter the rock mass, and in this rock mass you keep the canisters and make sure that when you are dropping them from top, because of the impact they do not get crushed or burst, and then use the backfill. Now, this is what is known as a deep geological disposal. A geotechnical engineer studies all these three situations. We were discussing about the leachate, and I gave you an example about the landfill. The landfills are exposed to the environment, rains come, the water interacts with the waste matrix and takes out the heavy metals. The same thing is going to happen here if you are not careful. So, what I am showing with the red arrows is that the activity may leach out if you are not very careful, if the disposal systems and the backfills and the compacted geomaterials have not been designed properly. And when I say design, this is the material which has to be worthy of tolerating all the attributes of the waste: high temperature, disintegration, radioactivity, chemical concentration and so on, clear. It should not get altered for years together. So, this is the undesirable situation. Now, the question is how would you check this? All these things are studied under the realm of post disposal. So, this is a big word, post disposal or near surface disposal people call it, or disposal of atomic waste, and this is where geotechnical engineers play a very important role. Now, I am sure you will realize once this type of situation occurs, the geomaterial contaminant interaction is going to take place. The attributes of the waste which are going to come out from this unit are going to interact with the geomaterial, which could be soil, which could be mineral, and hence that interaction is going to take place. This opens up lot of avenues for geotechnical engineers, and what are these avenues? First of all, site selection. What type of soil I should be using, where I should be dumping this waste, what type of geological formations which are worthy of locating or depositing or throwing my waste, alright. We call this as worthiness of the candidate repository. Selection of the site becomes very important. If India has to become a nuclear major, we should be having more and more disposal sites, clear, and that depends upon the attributes of the waste which you are generating. Selection of geomaterial itself, which are normally termed as barriers, covers, protective layers and so on. From where this type of soil will come, how would you place them, how would you make covers out of it so that nothing goes out of it, no radiations go out of it, water does not come into the system and so on. Post closure response, having done all these things, disposal, how the waste is going to interact with the geomaterials is a very big question. And truly speaking, these processes are going to occur over several tens and hundreds of years. So, when you are designing these type of systems, time becomes very important. Remember in the last lecture I was talking about the environmental impact analysis has to be done in two domains, that is time domain and distance domain. So, x, y, z, comma t becomes my motive. So, if at all this type of leakage take place, how the geo environment is getting affected, up to what distance, up to what time. Another way would be after this much time, how much would be the impact. So, this is how most of the establishments are designed, clear. And then comes the monitoring. Once I have disposed of everything, how would I monitor whether the system is behaving all right or not. So, if you understand all these steps, this is a very complicated thing, but very intricate, but very evolving, and it is basically catching the attraction of several guys nowadays. And this is where we talk about THMC, thermo, hydro, mechanical, chemical interactions. I think I have already given you enough feedback about what is the thermal effect. The waste might be at elevated temperature, how hydraulics of the waste is going to come into the picture at elevated temperature, how the mechanical properties are going to change, compressibility, shear strength, consolidation and so on because of chemical interaction. The second one is THMC, and B also I have added to this, biological. So, this is what is the coupling and interaction, which is the order of the day. Everybody is trying to master this, and I hope you can understand why this subject is becoming more important, because this has strategic importance, this has commercial importance and so on.